to. Okay. All right. That was the fastest changeover I've ever. Amazing how quick it can go. Okay, so I'm the last. I'm the last talk. So if you need to leave early, I won't be offended.
Hang on. Give me a hug, Alan.
Yay. All right, take it easy.
All right, Tim, he's making a difference in DC for us.
You guys are making all the difference. There is no problem.
Okay. Well, first of all, I guess I don't want to leave this conference without saying something about Carl. Carl takes a lot of grief from everybody, actually, and we kid and we make jokes and things, and I think he actually enjoys that largely.
Whatever attention I can get.
But it's rare, actually, that somebody will acknowledge him for the real work that he's done. And that's what I want to do right now, say that without Carl, at least from the U.S. HOU perspective, which is, I believe, where HOU started, without Carl, it would not have, A, it would not have started, and B, it would not have spread out to the global scene. And so I just wanted to acknowledge that publicly here.
Thank you. We're a team.
So the last thing that you'll see today is a little update on the Kepler mission. The U.S. people have seen things about Kepler before. So, but some of the others have not seen any of it. I really want to give an update that would be good for all of you.
Can you lower the screen projection?
Oh, yes, that would be good. Okay, so this is the Kepler website. One of my jobs as education public outreach person for the Kepler mission is to maintain this website. What that means mostly is to receive information and orders from people of what to put up on the website. But in the education area, these are things that I'm responsible for. Like, for instance, the Kepler Starwheel. That's actually Uncle Al's Starwheel with the Kepler's field of view on it. And I figured, well, what the heck? Let's put all of the naked eye stars that are known to have planets on the Kepler Starwheel too. Okay, so that Starwheel has all the naked eye planets that are known. Naked eye stars that are known to have planets, and the Kepler star field, which happens to be in primo viewing right now, and that's why the whole Kepler team is just going like maniac, trying to get these planet discoveries right now. This is the season; it's the summertime. Now we have developed a bunch of tools and interactive online, which is under models and exhibits. And then we also have some visuals that you might find useful in some of your presentations, movies and visuals, which I'd like to show you, and that without getting too far into it. This thing here, the Kepler Transitron, is the interactive, which is very useful at high school. It goes through the whole process of a simulation of collecting the data for making a light curve of a transiting planet. And I'm jumping ahead. I'm assuming you all know what a transiting planet is and what light curves are and so forth. If you don't, then I apologize for leaving out something.
That's the one we've used in Universe Quest.
Okay. The interactive?
Yes.
Oh, okay.
Yes,
Good.
definitely.
Good.
Okay, we show that?
You want? Okay. I'll show it very briefly. It takes to go. Well, I don't know. How long does it take to go through, really? Okay, so
takes a while.
It takes a while to go through it, but it's an interactive, it's a flash-based thing. You drag your telescope view over here, and then you go, and you pick a star, okay? You pick a star to get data on. You have a little, this is the really fast version of going through it. You have the characteristics of the star, G4, the mass, the radius, and a neat thing here is you can drag values into your note bar. You keep notes down at the bottom. You drag these things down, and so that gives you the temperature. You can also type in the note bar, and then it's a G4 star. So you got all that, you're ready to go to the next one. Here's where you record data. So when I press start, let's see. When I press start, this star up here is going to blink. Okay, so when that blinks, let me know, and I'll press the record.
That's real Kepler data.
With some of the stars, it is.
Yeah. Wow.
With many of the stars, it is actual corresponding to Kepler data.
Now,
Okay, now you don't actually have to go through the whole thing. You can give up on it and then just make your measurements. And this is a neat, you can drag the horizontal scale to measure the number of days to make it easy. So it's 0.7, let's just say 0.8, and you type that in here. It's only 0.8 days. Now this is amazing. This is a planet that goes around the star in 0.8 days.
0.8 days, planet goes around.
Less than a day, yes. I think I know which one this is, actually. Think about it. So, yeah. So, it's a hot one. Yeah. Okay, so this is, so what is this? 0.025. So this is 0.015, let's call it. Okay, so
This is where I would say the girls who are with have trouble reading.
They have trouble with that, yeah. Okay, but anyway, so then, now here's what, we're going through the math in a very black box sort of way. Okay, so first to figure out the distance to the star, again, you can drag these things up. It depends on the period, but for the equation, that has to be converted to years. And then it also depends on the star's mass. Okay, and that's it. So that's that's instructive right there. What does it depend on? Okay, without knowing the exact formula, you calculate it here, and it's 0.01 AU, and we can put that in our notebook. That's a close one.
It's close.
Yeah. Okay, then you want to figure out, was it in the habitable zone? Okay, well, you have to, let's see, the star's mass is 0.9, so I have to bring that down to 0.9, and the planet's distance is, well, it's way down. We have to drag this way down. And what was it, 0.015? Yeah, you don't think it's in the habitable zone. Okay, it ain't there. Okay, so it's not, so we put an N there. And then we have another formula. We want to know what's the planet's temperature. Okay, we think it's a hot one, right? Well, this is that old black body formula, right? So that depends on the star's temperature, the star's radius, and the distance of the planet. And then you can calculate temperature. It's 2794. Yeah, it'll melt iron. Okay, melting point of iron. Okay, well, how big is this planet? Well, that depends on the star's radius and how much the brightness dropped. Okay, and that's it. So you can calculate it, and it's 1.42. Okay, I'm going through this really fast. Okay, that was the fastest I've ever seen it. Okay, so this is it, and this happens to be Kepler 10b. It corresponds to Kepler 10b, which is the first rocky planet ever discovered. Okay, cool, huh? And if you want a view of what it looks like on the surface from an artistic representation of what it looks like on the surface, this is a molten iron, basically, with canyons. Yeah, that's what it really looks like. We know this for a fact.
It's 100 of an AU radius, so that would be about the size of our sun. We'd be right at the
Well, it's less than a day to go around the star.
Yeah, touching the sun. big is our sun?
pretty amazing.
Right.
So now what? Now what I started out to wanted to show you and this I'll demonstrate this how it works. Those of you who've seen this before know that we created an orrery out of Lego parts, and so the planets go around the star. And actually, I didn't bring the Lego one.
Okay, to answer your question, is you assemble that, Alan?
No, I'm not going to really assemble it. I'm just going to
answer your question
show it. Yeah, ask a question.
Well, you know, Suzanne and Michelle have that great exoplanet unit. Is there a way to get text data points out of this site too? Can you get a stream of data you could put into Excel? They have all these things, you know, how fast the planet goes into eclipse.
Yeah.
Can we get that detail out of the data yet?
The data point. Well, the data is essentially in light curves. And, you can get that out.
You can get that out of the light curves.
Yeah.
Okay.
I think.
Can you turn on your camera?
I think you get numbers.
Yeah. Let's see. Time. This is we got to make a movie recording, and okay. So here's this. You take a mag light or one of those lights that Connie had. And it can be a light like that, and this is a version that is sort of my portable version of what will be in a kit later in the fall.
So,
pardon? Yeah. So,
I mean, you can capture images of Salsa J and then measure data points.
Yeah. Well, okay, so yeah, it has a crank on the bottom.
Actually, Mark, if you could build in a voice control in the Arduino to stop start.
Grant has built some of our program, voice feedback, that program called Q. And voice control will be the next thing to do.
Okay, now we talked about this is a Vernier light sensor, and that's what we use with that orrery to get a real-time graph going. However, what I'd like to announce today, which is something we created just a month or so ago, is a light sensor that will create a real-time graph from a webcam or your laptop camera. It'll make your laptop camera into a light sensor. Okay, now we actually this is along the lines of what you were doing, so you'll be interested in this. This is actually, do I need that on anymore? I don't think so. Let me hide that. So that's on the website, Kepler website. Right below the orrery, there's this thing called Light Grapher. Okay. Oh, you know what? I don't see my scroll bar. Okay, I better do this. Then I have a scroll bar. Okay. So in order to actually make this work, I have to maybe I will need helpers. Because we'll set up, it turns out that you don't even need a light. A white ball actually works for this, as the star. Okay, so let me set up the white ball here. Okay, this can stand by itself, I think. Well, maybe I need somebody. I may need more than one person. Okay. So, what happens is if you click on this, it starts up the program, and it asks you, do you have a webcam attached, or do you want to use your laptop camera? So, I don't have a webcam. I'm just going to use the laptop camera, and it asks you for permission to allow something to come in here, and then it uses the camera to create a picture, I think.
What if you clicked on the USB camera? You okay the USB camera? camera?
I thought I did.
You've given your camera.
Oh, that's actually a good point. Yeah, there it is. Okay. Duh. Yeah, right. Yeah. Okay. So now what you do is you you click on.
You can measure your smile. The white light.
I have before I start this. Yeah. Okay. All right. So we have to close this. This is interesting, and then go over here and close that, and then try again. Okay, now I'm going to see if this. Unless I have to actually quit QuickTime altogether. No. Okay, there it is. There it is. Okay. All right. So now rest it on the table so it will stay, because we can adjust it. We can adjust it here. And one of the breakthroughs that I had, and I had a UC student programmer working on this, but it was a brilliant stroke of mine that I assigned him to do this. And also, I came up with the idea of confining the pixels that are under consideration to the pixels that are right around that ball. And so he created these different size things that or circles to confine it right to around the ball there. Okay, and once you're ready, then you can use you can use an orrery like that one. You can focus on the orrery, or you can use something that got tangled up in my suitcase. No. Actually, it didn't get tangled up in the suitcase. Okay, let's see if this works. Okay. So this is the very simple planet orrery, but it's difficult. It's difficult to hold it really steady. Okay.
Nice.
Does somebody want to try? Can somebody actually do this while I press the button, or somebody else press the button there?
I can do it.
You can do it. Okay. 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 It needs to go right in front of the ball. Okay. But this picture is going to disappear once you hold it steady. Once you get it going, you have to get it. You know, you get to get it into the swing. You have to get it.
Shorter? You leave the string shorter.
Yeah, I have a shorter.
She's got it.
Get more control.
Yeah, there you go.
There is a shorter one. Okay. Okay. So now, once you have it set up, then you click capture data, and here's our graph. But it's
Yeah, there it is.
yeah, I think it is. It is, and at any time you can auto scale it.
Like Spitzer.
Oh, cool.
Wow.
Don't get nervous. You're doing a great job.
Okay, you're improved, Rosa.
Oh,
Yeah.
yes.
Don't breathe, Rosa. Observer.
Good. Oh, wow.
Wow.
Nice.
Okay, so thank you, Rose. Now, the neat thing about this is that it's available for free for download from the website.
Wow.
Okay. Also, you can do it online. I mean, you can use it as an online in your browser, or you can download the Flash program and run it locally on your machine through its browser. So that if you don't have an internet connection, you can have downloaded it and still run it.
Wow.
So it's free. It also actually, what's amazing that it works, you don't have to make a Lego orrery for it. You can do it in this rather crude way.
Gee, this would be good for the rotating asteroid, too.
Yeah. So for this really long, actually, and what I have not succeeded in doing because I didn't have enough people to actually try it out, was to see if I could do a two-planet one. That orrery I showed you. That orrery is actually a two-planet orrery. This one, I can screw another planet onto it. But this, if we were to get one, I figure that if we were to get one person doing it like this, and then another person with this long one going above it, then we'd actually have a two-planet orrery. Wow.
Can someone else come?
Oh, wait a minute. Where's that? Where's that long one?
Is this one?
That is the long one.
How about 4?
Okay, so
Okay. Oh my God.
I think I have to get mine going first. Yours has to swing really far.
Planetary systems are messy.
Oh, one's going retrograde here. So,
Now, the biggest problem I have is your nose down.
oh, that's in fact to get down here. Oh.
Multi-planet in there.
interacting planet.
Okay, this is the 0.8-day orbit here.
Wow.
Oh, it's going.
Cool.
We got it.
Okay, so now we just need somebody else to press the button.
Okay, keep going. Oh, keep going.
This is very difficult.
They got it.
We have to go to,
Capture data.
yeah, just press capture data. No, that's on a, it's on a pin.
Gravity just.
Okay, when it's ready,
No,
Not ready, we're gonna get it. Okay,
give you one,
I'm gonna get mine.
give you two. Oh, I get the thing going, so I get to be God.
Yes.
Yes.
Ah.
Yeah, it's
I have to get my nose far away.
it's our arm closed. There you go.
Close enough.
Yeah.
Collision.
I'll just readjust the planet a little, the star a little bit here.
Damn.
A little bit lower, Mark, but that's going to be hard.
Oh, look at Marcus.
All right, do it.
Wow. Wow. Wow.
Well, when it's so close, far away, the angular side is about the same.
Nice.
Is it going?
Yes.
Yeah.
We're trying.
See, the people who are operating planets really can't see anything. Oh, hey, it reversed direction. That seems to not matter at all. In terms of the light curve, it doesn't care.
We're not seeing too much of that little one.
Yeah. Yeah, but I do see it.
I mean, it's there.
Oh, yeah.
But not enough of it.
Isn't that the type of problems that your kids just totally get into? But you have to make this work. Who gets the best graph?
Yeah, right. So, actually, that's a good point. You do want to have a dark color for your planet, or not white. But no, it
does the
doesn't.
graph show? Can the graph show?
It is just It was just looking at the overall brightness. So a darker color would show up not do as.
Just one line.
It would get less of a dip, I guess. If it's, yeah. Or no, a bright one would have less of a dip. A brighter color, less of a dip. Okay. So anyway, I thought you'd enjoy that.
We did.
And then the last thing I wanted to show, if I have time. Do I have time?
You have.
Do it.
Hey, I'm the last one. All right. Oh no, the conference controls quit unexpectedly. That means.
You reopen.
Okay, let's see if that works. No, this is not a good form. Let's see. I probably need to reconnect in ReadyTalk. Let me just stand by. Open meeting controls. This is a little lesson in how you do ReadyTalk. It's showing up there. What I wanted to show you was just a couple of the visuals that are available in the media section, and then because we've had professionally created animations. Oh, look, people are still in the conference. That's good.
We didn't give up.
Okay, and the recording is still going. Now, why can it
Cannot
not
connect
connect
to
to the
server.
server?
Please try again later.
What if you logged off? George Blues might log you off.
Really? Because our conference is over? Possible that our time is up.
Tell them 12:15, you're going to shut up?
Yeah, well, let's see if my browser still operates, okay? If I go back to
It's on.
It is on, okay. No, they wouldn't have taken this off. Let me go into the well, actually, I'm not going to do multimedia because I don't want to take the time to download these things. I have them already downloaded on my computer. I mentioned Kepler 10b. There's a really nice animation of Kepler 10b, and we've had it for a long time on the website that is just without sound. And then I got some musicians to donate music. So I think this is the one that has music with it. Maybe. So this is that hot one. This is the one that's over 2,000 degrees. Takes less than a day. That is just coming off the planet, I think.
Gravitational lock.
Yeah, I think that's
It's got a real hot spot.
we don't know that, but the theory was that. You can't see it too well here, but we're going through a canyon. Molten iron.
Wow.
And there's the, just so in case you forgot, this is a transiting planet. So there's one with that is just, this is a really short one to show comparative life zones. So if it's too close, this is the Goldilocks deal. If it's close in or far out. And this is to show the different types of stars. If you have a hot star at the top, medium star just right, or a cool star, which your soup is too cold. These are all available for download, different ways. NASA Kepler.nasa.gov. Or yeah, if you Google Kepler, come up. Let's see. There's a, what other one do I want to show? Here's an orbit. The Kepler. It's in a Earth-trailing orbit, and it has to. The only thing it has to. It's a very simple mission. It only has to rotate 90 degrees every 6 months so that the solar cells remain staying at the sun. But it's pointing the same place in the sky all the time at that region in the region in Lyra Cygnus area, which is on Uncle Al's Kepler Starwheel.
I
Wow.
like the way it's bigger than the Earth.
Yeah. This is
Big mission.
to exactly the scale. Yeah.
6,000 kilometer mirror.
Whoops, sorry. Okay, I think this is kind of neat, showing the optics of the telescope, actually. Light coming from the star, going however many light years through space. It enters our Kepler Telescope, which is a Schmidt camera, bounces off the mirror, goes to and that is our big camera. It's a 42-element CCD, 21 pairs of CCDs there. And it's about yay big. about a foot square. How big is Kepler spacecraft? The camera is, about a foot square, and it makes for a field of view that is over 100 square degrees, about 10 degrees squared. If you hold your hand out like that, it's about that area, maybe a bit more than the area of your hand, which is way bigger than most telescopes. The reason it needs that is because we want to look at 150,000 stars all at the same time, monitor them all.
So if we wanted to do the whole sky, how many telescopes would we need?
400. It's about 1/400th of the total sky. Yeah. Okay. And I think that's just about all I have to say, other than to give you some handouts. A, for the Lifelines project, which I talked about earlier. There's a little handout for that, and something about the Kepler mission.
Okay, thank you.
Thank you.
And now, Carl will give the close speech.
How could one follow such a wonderful presentation with, our hands-on activities, the data? Seems to me that epitomizes, a lot of our hearts and goals and spirit, and that's shared and it's free. And we're going to use it in Africa and Indonesia and around the world. So I just think that we have so much to give to the world, to each other, and to our children and teachers, that even though the challenges ahead are many, the accomplishments we've made up to now are, I think, quite outstanding. If we can just keep going, we're slowly succeeding more and more. We're into the French schools curriculum. We're into urban inner cores. We're into Portuguese hard schools. We're in Africa, and it's such an honor and pleasure to work with you all. If we can keep at it, I think the future is only going to get brighter and brighter and more optimistic. And I appreciate all of you so much, and I'm sure you appreciate each other so much. It's just an honor and a pleasure, and we'll get there somehow. Thank you. You're not going with us, right? No. I think that the conference officially is closed.
Get out.
I'll take it.
Thank you. Please stand by.